So let's start off Unit 3 together with stoichiometry, chemical formulas, and equations. Essentially here is the part that I think is going to be the most important for you for not only this class, but also Chem 2 and a number of other classes in your future. So it's pretty important that we learn how to balance equations properly and in turn use those balanced equations to solve stoichiometry problems. So what I want to do today is just learn to interpret the chemical equation with you and then do some simple balancing problems together. So interpreting the chemical equation, we're not going to go into too much detail, but essentially we have a few pieces of information here. We have abbreviations that typically go after our chemicals in our formula, and those abbreviations, G is for gas, L is for liquid, S is for solid, so 3 states of matter. But what we also have underneath is AQ. Because water is so important in chemistry, especially the chemistry that we're doing, but chemistry for everybody, if something's dissolved in water, it gets its own form. So AQ means aqueous, and that just stands for anything dissolved in water. So this chemical equation here doesn't have any aqueous portions, we have only gaseous portions. So when we're looking at chemical equations, we're looking at what's happening with respect to molecules when they react. So here we have methane reacts with oxygen to make carbon dioxide and water. And what stoichiometry does is it helps us determine how many methanes react with how many oxygens to make a certain number of carbon dioxides and waters, or any chemical reaction. We know that mass isn't created or destroyed in normal chemical reactions, so if we see that there's 1 carbon on the left side, there has to be 1 carbon on the right side. If we see that there's 4 hydrogens on the left side, there has to be 4 hydrogens on the right side. But oops, let's look at this one. 4 hydrogens on the left side, just 2 hydrogens on the right side. And that's where balancing comes in. And if we look at oxygen as well, 2 oxygens on the left side, 2 plus 1 oxygens on the right side. This equation definitely needs to be balanced. So how we can do that is just by placing coefficients in front of the numbers. So we're always going to change the number that goes in front of the molecule. We're never going to change these small subscript numbers, because remember, if you change the subscript, we're actually changing the identity of the molecule. So this is CO2, this is H2O. I know that I need to have, let's say, 4 hydrogens to balance this equation. I can't make this H4O, because not only would oxygen be unhappy to have 4 bonds, but that would change the identity and it would change the properties. This thing, if that were possible, might be some kind of a super acid, the likes of which we've never seen before. So we're not going to change the subscripts ever, we're just going to change the coefficients in front. And what that means is, it's never going to be H4O, there might just be 2 H2O molecules. So by placing a coefficient in front, we're just telling our reader how many of each molecule there are. Now if you're wondering, how do these always work out? We're representing real world equations, and if the equation or the reaction happens in the real world, that must mean that there's a fixed number of each one of these molecules participating as either a reactant or being produced as a product. So perhaps I think the next slide is balancing this one. Let's take a look at that. Oh, it's right here. So by placing the coefficient 2 in front of oxygen and placing the coefficient 2 in front of H2O, we can count up how many of each atom is on the left side, how many of each atom is on the right side, and from there we can see that it's a balanced equation. So what usually helps is to create a tally for these molecules. So let's look at carbon. How many carbons on the left side? Just 1. How many carbons on the right side? Just 1. Fantastic. Let's look at hydrogen next. 4 hydrogens on the left side. And here for H2O, we see that there's 2 H2Os, so 2 water molecules, each of which contains 2 hydrogen. 2 times 2 is 4, so 4 hydrogens on the right side. So equal numbers. And let's look at oxygen. We have 2 oxygen molecules, or 2 O2s on the left side, 4 total oxygens on the left, 2 oxygens in carbon dioxide, and 2 oxygens because there's 2 water molecules, so 4 oxygens per side. Now this one is just immediately balanced for you. I didn't show you the procedure for how I balanced it. We can balance this in a number of different ways, and I'll show you that next. But hopefully you can see here at least the result of having a balanced equation. We have the same number of each type of atom on the left side as we have on the right side. So here's an equation that we can do together, and what I think I might do is just turn off the PowerPoint so that we can do it on the board. But before I do that, we'll take a look at the steps, count the number of atoms on each side of the equation, balance the non-hydrogen and oxygen atoms first. If there's more than one element left, select the one which appears only once on each side of the equation. Balance the hydrogen atoms next, balance the oxygen atoms last. So because there's only carbon, hydrogen, and oxygen in this one, that means we're going to balance carbon first, hydrogen second, oxygen third. And the last step which we can do in these is to count the number of atoms on each side of the equation and ensure we balance correctly. The nice thing about balancing equations is we can check our own work. There's really no need. Perhaps it might be nice to have somebody else check our work to make sure it's correct, but after we're finished balancing, all we need to do is look at it and say, is there the same number of carbons on the left side and the right side? Is there the same number of hydrogens on each side? Is there the same number of oxygens on each side? If there is, the equation must be done correctly. If there's not, then we have to start looking at why. So let's get this out of the way here. And just while I can see its image superimposed on the board, I'm going to write it down and then move the screen for you. C3H8 plus O2. And that's good enough. We'll learn soon enough that combustion byproducts are always going to be water or water and carbon dioxide, depending on what's there. So transforms into water plus CO2. So again, the first thing that I'm going to do is I'm going to see how many of each type of atom is on each side of the equation. Maybe I'll make a tally right here. So carbon, hydrogen, oxygen, and let's look at left side, right side. So maybe I'll further divide this tally into pre-balanced and balanced for both the left and right side. So before balancing, number of carbons on the left side is 3. Number of carbons on the right side is just 1. Number of hydrogens on the left side is 8. Number of hydrogens on the right side is 2. Number of oxygens on the left side is 2. Number of oxygens on the right side is 3. And remember, it's important to look at each molecule on each side of the equation. So there's oxygen occurring in H2O. There's also oxygen occurring in CO2. So 2 plus 1 gives us 3. And now that we've tallied the numbers of each type of element on each side of the equation, we can see if it's balanced. So just immediately looking at carbon, I can see there's 3 carbons on the left, 1 carbon on the right side. I know this equation isn't balanced. So again, we'll start with carbon first. So if there's 3 carbons here and just 1 here, that's a simple fix. We'll just write the number 3 in front of carbon dioxide. Remember, we're always putting the number in front of the molecule rather than changing the subscripts, which would change the identity. So now that I've balanced carbon, we can look at hydrogen and oxygen, but also note that when you balance something, like I placed a 3 in front of carbon, that means 3 carbon, but it also means 3 times the 2 oxygens in here. So if there's 3 carbon dioxides, that contains 3 carbons and a total of 6 oxygens. So at this point, the right side now has 7 oxygens total, but we'll consider how many are on each side at each step, and that's why at the end we go through a tally to make sure that we have the same number of each atom on each side of the equation. So carbon's balanced. The next thing to balance is hydrogen, and I see on the left side there was 8, on the right side there's 2. That's a simple fix. I'll place the coefficient 4 in front of H2O, showing that there's 4 H2O molecules, so 4 times 2 is 8. Now there's an equal number of hydrogens on the left side and the right side. So recapping, let's see if carbons changed. 3 carbons here, 3 carbons here. Nope, that's great, hasn't changed, they're balanced. Hydrogen, 8 on the left, 8 on the right, they're balanced. Now finally, let's look at oxygen. So on the left side of the equation, I can say I have 2 oxygens. On the right side, I have 4 times 1 plus 3 times 2, so that's a total of 10. A mistake that I see happen often here is somebody will not consider the coefficients, and they'll just look at the atoms within the molecule, and they'll say, oh, okay, the right side has 3. Remember, the coefficient is multiplied by the number inside the molecule. So 4 times 1 plus 3 times 2 means 4 oxygens plus 6 oxygens, so 10. And we have 2 on this side. So if we multiply 2 by 5, we get 10. And this looks balanced, but let's do our tally anyway just to make sure. So again, carbon, 3 on the left, 3 on the right. That's balanced. Hydrogen, 8 on the left, 8 on the right. That's balanced. And oxygen, 10 on the left, 10 on the right. That one's balanced. So that's fantastic. This one's done. Let's go and do another example together. So let's look at methane plus oxygen, giving us carbon dioxide and water. And let's do our pre and post balancing tally again. Number of carbons on the left side, 1. Number of carbons on the right side, 1. Number of hydrogens on the left side, 4. Number of hydrogens on the right side, 2. Number of oxygens on the left side, 2. Number of oxygens on the right side, 3. So take a minute, pause the video, and see if you can complete this balancing equation. You might remember it from a couple of slides ago, but practice it nonetheless. If you find it easy, fantastic. You're ready to do more advanced problems. If not, no problem. Give this one a try and see if you can figure out what I've done previously. Remember, balance carbon first, hydrogen second, oxygen third, and once you're done the balancing, make sure to do a tally to check to see if your work's right. Okay, so let's go ahead with this one. 1 carbon on the left, 1 carbon on the right. That's already balanced, no need to add any coefficients there. 4 hydrogens on the left, 2 on the right. That's a pretty easy fix. 2 times 2 gives us 4, so now 4 on each side. And now 2 oxygens on the right, 2 plus 2 times 1, so 4 oxygens on the left. Placing the coefficient 2 in front of oxygen gives us 4 on each side. Now let's look at our tally. Number of carbons per side, 1 and 1 on the left and right. Number of hydrogens per side, 4 and 4 on the left and right. Number of oxygens per side, 4 and 4 on the left and right. So this one is balanced as well. So this is great. I think that's probably enough because I don't know if this was an hour quite a video. It was probably significantly less than that with the 2 combined. But typically I give you time for practice in between, and hopefully you took the opportunity to practice at home or wherever you're watching this from. So I'm going to put 1 or 2 questions, maybe 1 of each type or 2 of each type online in the form of a quiz, and you'll have until the end of the day on Friday to submit that quiz. So hopefully you take advantage of the class time that we would have had together to complete these assignments. Thanks for paying attention, and you were so quiet today as an audience, it was unbelievable.